Hello, welcome to representing linear non-proportional relationships. Just remember, when we're talking about linear, we're talking about forming a straight line. And we can represent linear relationships using tables. You can use an equation to describe the relationship between two quantities in a real-world situation. You can use a table to show you some values that make that equation true. In our first example, we have the equation y equals 3x plus 2, and that gives the total charge y for one person to rent a pair of shoes and bowl X number of games at Baxter Bowling Lanes based on the prices shown. Make a table of the values for this situation. And we see over here we have Baxter's Bowling Lanes, and it says it's $3 per game and that the shoe rental is $2. Now remember, when you go to the bowling alley and you're renting the shoes, you're only renting them one time. And then for each additional game, you would have to pay $3. So we're going to choose several values for X that makes sense in context. And then they want us to count by ones. So this is X, the number of games. And then we have for 1 game, 2 games, 3 games, and 4 games because they wanted us to count by ones. Y is how much it's going to cost in dollars. Okay, so what we're going to do, this is our input, and then we are going to substitute this into our equation for X. And then that's going to give us our Y. And that's what they're doing down here in step 2. So they want us to use the equation y equals 3x plus 2 to find y for each value of X. And we said that these two were 3 and 4. So I'm just going to go ahead and add those in. So what I'm going to do is just substitute each time my value for X to find out what Y is. So they've already done 1. So for 1 game, it's going to cost $3 for the game and $2 for the shoes. And so altogether, the game is going to play is going to be $5. For 2 games, 2 times 3 is 6, and 6 plus 2 is 8. So it's going to cost us $8 to play 2 games and rent a pair of shoes. If it is 3 games, we're going to replace the X with 3, and then add 2. So 3 times 3 is 9. 9 plus 2 is 11. And then for 4 games, replace the X with 4. 3 times 4 is 12. 12 plus 2 is $14. Okay? So this gives us values for each game that we played, how much it's going to cost us. Let's take a look at the Your Turn, number 1. It says Francisco makes $12 per hour doing part-time work on Saturdays. He spends $4 on transportation to and from work. The equation y equals 12x minus 4 gives his earnings after transportation costs for working X number of hours. Make a table of values for the situation. And the reason it's minus 4 is because even though he's earning $12 per hour, that money goes up, he's having to spend $4 each day for transportation costs. So that has to come out of there. So let's see, if we do, let's do 2 hours. Let's go up by 2s. Okay. So if he works 2 hours, we're just going to replace the X in our equation with our X value, and then we're going to find out how much he actually made that day. And this is kind of what he's bringing home, is what they're looking for. So if he works 2 hours, that is 24 minus 4, which is 20. So that day he brings home $20. If he works 4 hours, well, 4 times 12 is 48. 48 minus 4 is 44. So 4 hours, he would bring home $44. If he works 6 hours, that's 72 minus 4 is 68. And if he works 8 hours, $12 times 8 is 96. 96 minus 4 is 92. So he'll bring home $92 that day. Okay? So we have our input, which is our x value, and then we have our output, which is our y value, which is what we're looking for. Okay? We can examine linear relationships by recalling that a proportional relationship is a relationship between two quantities in which the ratio of one quantity to the other quantity is constant, which means the change is the same. The graph of the proportional relationship is a line through the origin. Relationships can have a constant rate of change but not be proportional. Okay? So it says the entrance fee for Mountain World Theme Park is $20. Visitors purchase an additional $2 tickets for games, rides, games, and food. The equation y equals 2x plus 20 gives the total cost y to visit the park, including purchasing X number of tickets. So they're giving us this equation, which tells us that each ticket, which is X, is going to cost $2, and it's $20 just to get into the park. Okay, so that is their total amount that they're having to pay. They want us to complete this table that if they just go in the park and they don't ride any of the rides, they don't buy any food, they don't play any games, they just enter the park, then we know that if I replace the X with 0, that's 0, 0 plus 20, so it's only going to cost them $20 to get into the park. But say they want to ride a couple of rides, so they're going to buy 2 tickets. So we're going to replace the X value with the 2, and we're going to solve for Y. So 2 times 2 is 4. 4 plus 20 is 24. So it's going to cost them $24 if they purchase 2 tickets. What if they purchase 4 tickets? So we'll have the 4 replacing the X this time. 2 times 4 is 8. 8 plus 20 is 28. If they buy 6 tickets, I have 2 times 6 is 12. 12 plus 20 is 32. And say they buy 8 tickets. 2 times 8 is 16. 16 plus 20 is 36. So here's our table of values. If they purchase this many tickets, how much it's going to cost them when they go to the theme park. Now we're going to take these, and these are ordered pairs. Here's my X value and Y value. And remember, when we have ordered pairs, X is our first value, Y is our second value. So they said X is the number of tickets, that is your value along the X-axis. Y is the total cost in dollars, and that is along your Y-axis. And they want us to plot these ordered pairs. So my first ordered pair is 0, 20, and that one is right about here. Our second ordered pair is 2, 24. So we're going to come across the 2, and then we're going to go up to 24. Our third ordered pair is 4, 28. Graph it going across to 4 and up to 28. Our next one is 6, 32. Go across the 6 and up to 32. So there. And then our last one is 8, 36. So we'll go across 8 and up to 36. And you'll see that if I were to draw a line through this, I would have a straight line. Okay? We need to find the rate of change between each point and the next. Is that rate of change, is the rate constant? Okay? Remember, when we're looking for the rate of change, it just takes any two points, and we're going to find the difference between them. Okay? So let's pick these two. So if I have 0 and 2, so I'll have 2 minus 0 on the bottom, that's my x values, and 24 minus 20, that's 4 over 2, which is 2. Okay. Let's pick another set. Let's do 4 and 8. So let's go 8 minus 4, those are my x values, and 36 minus 28. This is 4, this is 8. 8 divided by 4 is 2, so it's still constant rate of 2. I can pick any set and it's all going to come out. So my constant rate, so yes, the rate of change is 2. Calculate yx for the values in the table. Explain why the relationship between the number of tickets and the total cost is not proportional. So now we're just going to find the constant just looking at these. Well, if I have 20 divided by 0, it's 0. Or it's can't be done. It's undefined. Then I have 24 divided by 4, or no, sorry, 2. Get the right one here. That's 12. And if I take 28 divided by 4, I get 7. And if I take 32 divided by 6, I get 5.5. So see how these my constants just are not working, are they? That's because it's not proportional. So the relationship between the number of tickets and the cost is not proportional because there is not a constant. Okay, so the relationship as we don't have a constant. So even though my rate of change is the same, my constant is not. Also, if you've noticed, if I were to draw a line through those, I do have a straight line. It is linear. But is it going through the origin? No. So I'm also going to add here, when graphed, it does not, when graphed, it doesn't pass through the origin. Okay, so there's two ways that we can prove that even though this is linear, it is non-proportional. Okay. Part 2 will be representing using graphs.